In this video, I'm going to show you how to do AQA A-Level Maths Paper 1, June 2018, Question 8. My name is Sunil Tanna. I'm an author and tutor. I'm available for one-to-one tuition, both online and in person. I live in Buckinghamshire, England. The diagram shows a sector of a circle, OAB. C is the midpoint of OB. AOB is theta radians. Given the area of the triangle OAC is equal to the 1/4 of the area of the sector OAB, show that theta equals 2 sine theta. Okay, the area of the triangle, we can use the formula half AB sine C. So triangle is half AB sine C. Now you remember A and B, the small letters, are sides, and the capital letters, in this case capital C, is an angle. And the rule is that the capital letters for the angles have to be correspond to their opposite side. So if this angle theta is C, this side over here would be C, little c. And these would be A and B, whichever way around we want them. Now, substituting what we know about the triangle into this, we would say the triangle is half little a, or length OA, is the radius of the circle, so times r. Little b, or OC, in the triangle is half the radius, so half r. And then, of course, angle C is the same as theta, so sine theta. The area of the sector is given by the formula half theta r squared, provided, of course, that the angle is measured in radians. Now, we know that the sector is 4 times as big as the triangle. So, in other words, 4 times half r sine theta is equal to half theta r squared. Now, we can simplify the left-hand side because it has 4 times a half, which of course comes to 1. R times r becomes r squared sine theta, and that's equal to a half theta r squared. Dividing both sides by r squared, we'll get sine theta is a half theta, and then timesing by 2 sine theta is equal to theta, which is the result we wanted. Next part of the question says, using the Newton-Raphson method with theta 1 equals to pi, find theta 3 as an approximation for theta and give your answer correct to 5 decimal places. So the equation that we're trying to solve is 2 sine theta equals theta. Now, the Newton-Raphson method allows us to solve an equation of the form f of x equals 0, and we use this iteration, xn plus 1 is equal to xn minus f of xn divided by its derivative f dash of xn. Now, in this case, what we're going to do is we're going to use theta instead of x. So first of all, we need an f of x or an f of theta that's equal to 0. So rearranging the equation at the top, if we subtract theta from both sides, we'll have 2 sine theta minus theta is equal to 0. So our f of theta is 2 sine theta minus theta, which allows us to now set up the iteration. Theta of n plus 1 is equal to theta n minus 2 sine theta minus theta, and then on the bottom of that we have to differentiate with respect to theta. The derivative of 2 sine theta is 2 cos theta, and the derivative of theta is 1. So 2 cos theta minus 1 is on the bottom of that fraction. Now all we do is we use the iterative function in our calculator. What you can do is put in your initial answer as pi. So type in pi and press equals, and then write this formula, but wherever there's a theta, write answer. So it would be answer minus 2 sine answer minus answer divided by 2 cos answer minus answer. So if we do that, theta 1 is pi, which we're given. Then we press equals, and it will give us our second value of theta. And theta 2 comes out to 2.094 395 something. theta 3 comes out to 1.91322, right, rounding to 5 decimal places as requested. Finally, they asked us to work out the percentage error. It says, given that the theta is 1.89549 to 5 decimal places, in other words, the exact value is that, or the correct value is that, find an estimate for the percentage error in the approximation found in part B. So the percentage error is the difference, the absolute value of the difference between the estimate value and the correct value, divided by the correct value, times 100. So in other words, it's estimate minus actual divided by actual times 100. And of course we will have to make the top of that fraction positive, so we ignore the signs if there was a negative sign. So in this case, it will be the estimate was 1.91322. The correct value is 1.89549 divided by 1.89549 times 100. Put that into calculator and you'll get 0.935. Of course, it's the percentage, so 0.935%. And that completes question 8.